When we think about the ideal gas law, it gives us an easy way to calculate the interactions between pressure, temperature, number of moles, and volume. To really understand the behavior of gases, we need to think about the kinetic molecular theory. It's a simple theory based on a few precepts. The first is that the volume is going to be very large compared to the number of particles. There's going to be a lot of space between the particles, which means that there's going to be limited interaction between these particles. The second is that the particles are always in motion, random motion. The third is there is no attractive forces between these particles. And the fourth is that the kinetic energy, the movement of these particles, is directly proportional to the temperature. Well, what does this mean? Well, if we think about the ideal gas law, we know that pressure is directly related to temperature. If we increase the temperature, we increase the pressure. What does that mean? Well, what we're doing by increasing the temperature is we're increasing the energy in these particles. As these particles start to move faster, they will bump into the sides of the vessel that are holding us, increasing the pressure. If we think about number of moles to a volume, as we increase the number of particles, it's going to increase how much volume is necessary because the particles need to stay further away from each other. The kinetic molecular theory gives us a way to understand the calculations we've been doing with the ideal gas law. Remember that all particles are in random motion. In gases, they're far apart, there's no interaction, and they're usually moving very fast.